Let's talk about stack, heap, and pointers in Rust. In Rust, the stack is a region of memory where data is stored in a last-in, first-out order. When a function is called, its local variables are pushed into the stack, and when the function returns, those variables are popped off the stack. The stack memory is typically faster to allocate and deallocate than heap memory, but it's also more limited in size. The heap, on the other hand, is a region of memory where data can be stored dynamically during runtime. Heap memory is slower to allocate and deallocate than stack memory, but it's also much larger. Rust includes a feature called smart pointers, which manage heap memory and deallocate it when it's no longer needed. This is useful to prevent memory leaks. There are 4 types that can be used to allocate values to the heap in Rust: box, RC, arc, and vec. Here, the value 5 is being allocated on the heap using the box type, which is a smart pointer that will automatically deallocate the memory when it goes out of scope. And in this example, we use RC to create a reference-counted pointer. Here, the value 5 is being allocated on the heap using the RC type. RC allows multiple variables to refer to the same heap allocated value, and will deallocate the memory only when the references to it go out of scope. We can also use an atomic reference counter, or ARC, to create a thread-safe reference-counted pointer. Here, the value 5 is being allocated on the heap using this ARC type. ARC is similar to RC, but it's thread-safe and allows multiple threads to refer to the same heap allocated value. Finally, using vec, or a vector, to allocate a dynamic array on the heap. A vector or a dynamic array is created on the heap using the vec macro. Vec is useful for storing a variable number of elements and can automatically resize when necessary. In general, box type is useful for creating a single owned heap allocated value. RC and arc types are useful for creating shared references to heap allocated values. Vec is useful for creating dynamic arrays that can grow and shrink as needed. Finally, in Rust, a reference is a way to refer to a value without taking ownership of it. A reference is represented by the AND operator, and it can be used to borrow a value from its owner. The borrowed value can be read or modified, but the owner remains in control of the value's lifetime. This allows multiple variables to refer to the same value without worrying about ownership and memory management. In this example, x is a mutable variable of type i32 with a value of 5. Y is a mutable reference to x. The AND mute operator creates a mutable reference to the value of x. The reference y allows you to modify the value of x without taking ownership of it. This behavior is a bit similar to how we use pointers in other languages.